In today's class, I'm going to cover the empirical formula. Okay, so empirical formula is nothing but a simple ratio formula. अगर आपके different type of formulas होते हैं, you have molecular formula, you have molecular formula. Inorganic chemistry will be dealing with structural formula. And the third type of formula is basically our empirical formula, right? तो आपका मॉलिक्यूलर फॉर्मूला इज अ फॉर्मूला जहां पर उस पर्टिकुलर मॉलिक्यूल में जो एलिमेंट्स हैं उन एलिमेंट्स के कौन से एटम्स कितने एटम्स हैं. लाइक फॉर एग्जांपल सल्फ्यूरिक एसिड का जो मॉलिक्यूलर फॉर्मूला है दैट्स H2SO4. हाइड्रोक्लोरिक एसिड का जो मॉलिक्यूलर फॉर्मूला है दैट्स HCl. तो सल्फ्यूरिक एसिड के अंदर जो है टोटल वी हैव 2 हाइड्रोजन, 1 सल्फर एंड 1 ऑक्सीजन. हाइड्रोक्लोरिक एसिड में वी हैव 1 हाइड्रोजन एंड 1 क्लोरीन. ठीक है. अच्छा, अब then we have C2H6O. This can be a formula for ethanol, C2H5OH. तो ये C2H5OH आपको बता रहा है स्ट्रक्चरल फॉर्मूला ऑफ अल्कोहल, जहां पर आपके पास you have 2 carbons and with the 2 carbons the 5 hydrogen have been satisfied. और उसके बाद ये जो सेकंड कार्बन है उसको फर्दर सेटिस्फाई किया विद द ऑक्सीजन. ठीक है. एंड देन हाइड्रोजन. तो ये बेसिकली अगर हम C2H5OH के फॉर्म में C2H6 को लिखते हैं तो दिस इज गोइंग टू बी अ स्ट्रक्चरल फॉर्मूला. तो स्ट्रक्चरल फॉर्मूला हम नॉर्मली ऑर्गेनिक केमिस्ट्री में लिखते हैं और इससे आपको एक फॉर्मूला एक मॉलिक्यूल का स्ट्रक्चर पता चलता है कि किस तरह से वहां पर डिफरेंट एटम्स जो हैं वो बॉन्ड हो रहे हैं. ठीक है. हाउ दे आर बॉन्डिंग विद, राइट. फॉर एग्जांपल ऑक्सीजन जो है वो दो साइड से, एक तरफ से कार्बन से, एक तरफ से हाइड्रोजन से बॉन्ड हो रहा है. तो ऑक्सीजन की जो वैलेंसी है वो -2 है, उसके पास ऑलरेडी 6 इलेक्ट्रॉन है. इट इज डेफिशिएंट ऑफ 2 इलेक्ट्रॉन. तो एक इलेक्ट्रॉन वो एक कार्बन से लेगा, दूसरा इलेक्ट्रॉन हाइड्रोजन से लेगा. इस तरह से वो उसकी वैलेंसी जो है या उस वो इट विल बिकम स्टेबल. ठीक है. तो स्ट्रक्चरल फॉर्मूला इज एक्चुअली the way how molecular formula can be represented, where all the atoms किस combination में कौन सा atom एग्जिस्ट करेगा इन अ मॉलिक्यूलर स्ट्रक्चर. ठीक है. अच्छा, अब अगर फॉर एग्जांपल मॉलिक्यूलर फॉर्मूला को अगर हमें सिंप्लीफाई करना है, ठीक है, जैसे हमारे पास फॉर एग्जांपल मॉलिक्यूलर फॉर्मूला ऑफ हाइड्रोजन पेरोक्साइड इज H2O2. अगर मुझे इसको सिंप्लीफाई करना है तो मैं इसको सिंप्लीफाइड फॉर्म में अगर 2 हाइड्रोजन एंड 2 ऑक्सीजन, ये 2:2 के रेशियो में इसको सिंप्लीफाई करूं तो 1:1 का रेशियो हो जाएगा. इफ यू डिवाइड इट बाय कैंसिल इट आउट तो आपका जो HO जो है दैट इज बेसिकली इज गोइंग टू बी द empirical formula. It's going to be the empirical formula for the molecular formula which is H2O2. So किसी भी molecular formula को अगर हम ratio form में लें, simple ratio form में लें तो बेसिकली बन जाता है आपके पास empirical formula. तो molecular formula और empirical formula के अंदर रिलेशन होता है कि अगर empirical formula को हम n number of times से multiply कर दें तो वो फॉर्म करता है molecular formula. So this relationship we need to understand and we need to know about it. इसके ऊपर भी आपके कुछ questions based होते हैं जिनको मैं अभी इसी वीडियो में कवर भी कराऊंगी. अगर मेरे पास empirical formula HO है, उसको अगर n मीन्स यहाँ अगर मैं 2 से मल्टीप्लाई करूंगी तो मेरे पास मेरा मॉलिक्यूलर फॉर्मूला आ जाएगा H2O2. या H2O2 को अगर मैं 2 से डिवाइड करूंगी, ठीक है, इसको सिंप्लीफाई करूंगी तो आई विल बी गेटिंग एम्पिरिकल फॉर्मूला दैट इज बेसिकली माय HO. और अगर 2n की वैल्यू अगर 2 है उससे मल्टीप्लाई करूंगी देन आई विल बी गेटिंग माय मॉलिक्यूलर फॉर्मूला. सो दिस इज बेसिकली द रिलेशनशिप. It's a relationship between the empirical formula and molecular formula. So n जो भी n number of times अगर आप empirical formula को multiply करेंगे तो आपको molecular formula मिल जाएगा. और molecular formula को अगर आप n number से divide करेंगे जहाँ सारे atoms जो हैं वो n number से n variable से, ठीक है, डिवाइड होंगे तो आपके पास आ जाएगा एम्पिरिकल फॉर्मूला. ठीक है. तो दिस इज बेसिकली दीज आर 3 डिफरेंट टाइप ऑफ फॉर्मूलाज. वन इज मॉलिक्यूलर फॉर्मूला, सेकंड इज योर स्ट्रक्चरल फॉर्मूला एंड थर्ड इज योर एम्पिरिकल फॉर्मूला. ठीक है. तो अब राइट नाउ इन दिस वीडियो आई एम गोइंग टू एक्सप्लेन हाउ टू कैलकुलेट द एम्पिरिकल फॉर्मूला. ठीक है. अच्छा, अब यहाँ पर हमारे पास सिलेबस में एम्पिरिकल फॉर्मूले की एम्पिरिकल फॉर्मूला हम डिराइव करते हैं. We derive the empirical formula if certain values or certain figures are given to you. अगर आपको हर एलिमेंट, ठीक है, जो भी एलिमेंट वो पर्टिकुलर मॉलिक्यूल बना रहा है, उस एलिमेंट का मास पता हो या फिर उसका परसेंटेज पता है या फिर उसका परसेंटेज कॉम्पोजिशन पता है, तो आप एम्पेरिकल फॉर्मूला इजीली कैलकुलेट कर सकते हैं। ठीक है, ओके। इन ऑर्डर टू कैलकुलेट द एम्पेरिकल फॉर्मूला हमारे पास दो तरह से सवाल आते हैं, या तो आपको ये एलिमेंट्स जो जो एलिमेंट्स इस पर्टिकुलर एम्पेरिकल फॉर्मूला को बना रहे हैं इस कंपाउंड में है, या तो उनकी हम परसेंटेजेस आपको दे देते हैं सब क्वेश्चन के अंदर। either they give you the percentages of the element or they give you the masses of the element which is forming the empirical formula. So let's do it on the basis of the percentage. Now, whatever the elements are forming this particular compound, so what you'll be doing, you'll be making that many columns. So this particular compound has got just two elements. So I'll be making just two columns over here. Okay. One column will be there for sulfur, and the another column will be there for oxygen. What I'll write down, sulfur, and the other column I'll write down the oxygen, because these are the only two elements which is forming this compound, and we are actually finding out the empirical formula. Now what will you will do in the first step, if the percentage is given or the mass is given to you, so you will write down the percentage of sulfur, which whatever is given to you, and similarly you write down the percentage of oxygen. And then in the first step itself, you will be dividing the percentage or the mass, whatever is given, by the AR of the element. Okay, you will divide it by the AR of the element. So in this case, the AR of sulfur, okay, you know it how to get it, the AR of sulfur, using the periodic table. Periodic table is at the back of each paper, whether paper 2 or paper 1. It is not given in the paper 4, but then the paper 4 you will be given the values, the AR values, along with the question. So 50 divided by the AR for sulfur, that's 32, and oxygen, the AR is 16. You're not going to take the MR of oxygen, you have to take the AR of oxygen, because this is an atom, right? So we will not take 32, we'll just take 16. Now in the step 2, you will be dividing 50 by 32 and 50 by 16. On division, we are getting 50 divided by 32, we are getting 1.5625, and 50 divided by 16, we are getting 3.125. Now in the second step, whatever the values we are getting, now we have to find out the ratio of between sulfur and oxygen. So what we will do is, in dono values mein se whichever does the smaller value, will divide both the values by that. The smaller value is 1.5625, and the same 3.125, again we will be dividing it by the smaller value in order to get the ratio. So here the ratio we are getting 1, and here the ratio we are getting 2. So now we have the ratio for the sulfur and for the oxygen. So that means the sulfur and oxygen, they exist in the ratio 1:2 in this particular compound. So my formula is SO2. So on the basis of the calculation of the empirical formula, I know that the empirical formula for sulfur for this compound is SO2. That means my compound is basically sulfur dioxide. Okay. So in this question number 1, they have given us the percentages. So what was the step 1? We were dividing the whatever the percentages we are getting, we are dividing that by AR, right? And then after that, whatever the value we are getting, we are dividing it by the smallest of the value. Okay, whatever the smallest, in order to get the ratio. And that ratio, वो जो ratio आपको मिला, that you will be writing it down in the formula. So this is my empirical formula. Now let's move on to the case number 2. This is scenario number 2. This is case number 2, right? This was case 1. Now in the case 2, what they are doing is, they have given you, in the case 2, they have given us the masses. You can see the gram here. So in the question case 1, they have given us the percentage. In case 2, they are giving you the masses. So they have given us the mass of nitrogen, and they have given us the mass of hydrogen. So I'll be making two columns here, because the elements which are present in this compound are nitrogen and hydrogen only. So I'll make two columns for nitrogen and hydrogen. Okay. Now after this, what we will be doing next is that we will be writing down the mass or whatever the value you have been given, 1.4 for nitrogen and 0.30 for hydrogen. And then as we have done in the case one, we are going to divide them by the AR. So AR of nitrogen, you'll get it from the periodic table, that's 14. And AR of hydrogen, you'll get it from the periodic table, that's 1. After dividing the value by the ARs, here in the nitrogen, I'm getting 0.1 as the value on division, and I'm getting 0.30 when I divide by 1. Now the step 2, what we were doing in order to find out the ratio, whichever the smallest value is there, we'll be dividing that these values by that value. So 0.1 out of these two values is the smallest. So we'll divide the 0.1 by 0.1 and 0.30 by 0.1. On dividing, we get the ratio of 1:3. So nitrogen exists in the ratio 1 and the hydrogen exists in the ratio of 3. So we get the empirical formula, that's NH3, and we know that now the compound is basically ammonia. So this is how we actually calculate the empirical formula. So they give you the information about the elements either in the form of a percentages or in the form of the masses. So as many elements you have, if they in this scenario 1 and 2, they both have the 2 elements only. They can be more than 2 elements, they can be 3 elements, or they can be 4 elements which comprise that compound. So accordingly, you will be making that many columns. Is it clear? Okay, now in this particular scenario, this is another scenario where they have given you the empirical formula. They have already given you the empirical formula, and from the empirical formula, they're asking you to calculate the molecular formula. Likewise, I have given you the example. If I have HO, if I have an HO as an empirical formula, if I have HO as an empirical formula, if I multiply it by 2, then the molecular formula is going to be H2O2. Is that clear? So what I'm supposed to do here is that I need to find out the value of N. This is a relationship between the empirical formula and the molecular formula. That empirical formula, N number of times when you multiply it, you get the molecular formula. So you need to find out what is the value of N. So when you know the value of N, then the empirical formula you'll multiply by N in order to get the molecular formula. Okay, so now from empirical formula, we have to find out what is the molecular formula. Now for such questions, the data which is given to you is definitely the empirical formula is given to you, and then they give you the MR. Okay, now MR means that's some relative molecular mass of the compound. And we know that empirical formula, if we have the empirical formula correct, then from if we have a molecular formula correct, from the molecular formula, we can easily calculate the MR, because what is that? What is the MR? It's a sum of all the relative atomic masses which exist in a molecule. So molecular formula, if you have a correct molecular formula, then that means from there you can calculate the MR. So MR is equal to the molecular formula, because MR you determine from the correct molecular formula. So there's a relation. So that means wherever we have we say that empirical formula N number of times equals to molecular formula. So what we can do is we can substitute the molecular formula by MR, because if we have the correct MR, that means it's coming from the molecular formula. So we have a new established relationship, that is the empirical formula N number of times equals to molecular formula, relative molecular mass, MR. Okay. Acha, now let's see what the information is given to you. The empirical formula is CF2. So now I'm writing it down here. Empirical formula they have given us, that's CF2, right? We don't know what is the value of N. Nothing of the kind, no information is given to us which help us to determine the N value. Ab N hame compute karna hai. As soon as we get the value for N, we can multiply the empirical formula in order to get the molecular formula. So our main objective is to find out the value for N. So we have the empirical formula written from the question, that's CF2. And I already told you that the molecular formula we can substitute by MR, or relative molecular mass. So CF2 N number of times equals to, what is the MR? It's basically 100. So I'll write down 100 over here, right? I actually know the atomic masses, the relative atomic masses of carbon and fluorine. So relative atomic mass for carbon is basically 12, which I've taken from the periodic table. And for the fluorine, fluorine, it's 19, right? And the empirical formula is CF2. So what we'll have, we have 12 plus 19 into 2. And this is n number of times equals to 100. Okay, so 12 plus 19 into 2 makes it 38 plus 12, that makes 50. So 50 n equals to 100. So we have the value of n equals to 2. When we have value of n equals to 2, so now what we will do over here is we will be multiplying the empirical formula. We will be multiplying empirical formula, which is my CF2 with 2 in order to get the molecular formula. So my molecular formula is C2F4. So that's my answer. So when the empirical formula is given to you and the MR is given to you, so you can easily calculate the molecular formula. So this is the process. What do? Is we write down the empirical formula n number of time equals to relative molecular mass, because we know that the relative molecular mass comes from the right molecular formula. So we are substituting the molecular mass in place of molecular formula. So this is how we make our own equation, and then we put the values on the relative atomic mass of different elements, and we get the value for n. Or uske baad we find out, when we have the value of n, then we multiply the empirical formula with n and we get the molecular formula. Okay, now I have a question number 2, exactly the same. Now just let's proceed with the calculation. The empirical formula is CH2 and MR is 42. So we know that empirical formula n number of times will be equal to the relative molecular mass, which is actually coming from molecular formula, which is 42. Now we know the AR for carbon and for hydrogen. AR for carbon is basically 12n, plus we have 2n over here. 1 is the atomic mass for hydrogen, so 2 multiplied by n is equal to 42. So when you add them up, so you have 14n equals to 42. So value of n, 42 divided by 14, we get the value here. Value of n is 3. So what we will be doing next is empirical formula. N ki value we know it's 3, so we'll multiply the empirical formula with 3 in order to get the molecular formula. So the molecular formula will be C3H6. So that is your answer. This is my molecular formula, which I derive from the information which is given to me. Okay. Now let's do the third one more, last practice. Okay, empirical formula is CH, relative molecular mass is 78. So we have CH n number of times equals to 78. Now carbon is 12, n plus hydrogen is 1n is equal to 78. So we have 13n equals to 78. So value of n, when you divide 78 by 13, 78 divided by 13, n value is 6. So CH, the value of n is 6. We'll multiply the empirical formula with 6 and we'll be getting the molecular formula. So the molecular formula is C6H6, and that's a formula for benzene. Okay, so this is how we'll be calculating the molecular formula if we know the empirical formula and if we know the relative molecular mass. So that is the second type of question related to the empirical formula. Now let's move on to the third type. Okay, student, this is the category 3, right? This is the category 3, which is the category 3 questions which are related to the empirical formula. I'm just reading out the question. Says that calculate the empirical formula for compound form when 20.7 grams of lead forms 23.9 grams of lead oxide. So basically the compound is lead oxide and they have given you the information about lead. What about the oxygen? How will you get to know what is the mass for an oxygen? So we know that we have one element, that's lead for sure, and another element is oxygen. Okay. Now what we will do similarly like before, we will be making two columns here. The lead is already given to us, so we will be writing the value for lead here. It's mass of lead 20.7. Okay, it is basically mass. You will be dividing it by AR. So AR for lead is 207, right? The mass is 20.7 and AR is 207. Now, what about oxygen? They have given us the mass of lead oxide. So what we'll do, lead oxide mass, from this we will be subtracting the mass of lead. When we'll be subtracting the mass of lead, we will be getting the mass for oxygen, and that we will be dividing it by the AR for oxygen. So here what we have is mass of lead oxide is 23.9. From this we will be subtracting the mass of lead, that's 20.7, and we will divide it by 16. Okay, so now on computing, we will be getting the value here. It's 0.1. Fine, we'll be getting the value 0.1 here, and we'll be getting the value 3. Sorry, it will be this, the value is going to be 0.2. Fine, we'll be getting the value 0.2. Now, this was the first step. In the second step, in order to find out the ratio, like we have done in the previous question, we will be dividing it by the smallest value. So out of these two, the small value is 0.1. And this also will divide by the small value in order to get the ratio. So we are getting 1 here and we are getting 2 here. So the empirical formula will be PbO2, because lead and oxygen, they are in the ratio of lead 1:2. Now, only change when is that here they have given you the mass of an element and they have given you a mass of a compound. And this particular compound comprises of two elements. So whatever the mass of a compound has been given to you, from that you deduct, you subtract the mass of the element, so that you will be getting the mass of unknown mass of the element, that is oxygen. So this is how you'll be getting it, and then the same step need to be followed. You, on the ratio basis, you will determine the empirical formula of the compound. Now, this is the last category, which is related to the empirical formula calculation. Now, look here, this is little different from the previous examples of previous type of questions we have been doing. Now they have given us the hydrated salts, hydrated salt. Okay, what are hydrated salt? Hydrated salts are the salts जहाँ पर हमें जहाँ पर water crystallization is associated with the salt. Like for example, we have MgSO4 dot NH2O, or we have copper sulfate with associated with 5 molecules of water. So these are hydrated salts. ठीक है, अब यहाँ पर हर एक मॉलिक्यूल के साथ डिफरेंट वाटर मॉलिक्यूल एसोसिएटेड होते हैं. ठीक है, these water molecules are known as water of crystallization. इनको हम water of crystallization कहते हैं. ठीक है, क्योंकि this is known as water of crystallization. ठीक है, because these are, if they are there, these water molecules are associated with the salt molecules, they help in forming the crystals of these salts. Okay, because of these water molecules associated with them, combined with them, these salts exist in the crystalline form, crystal form. Okay, now if on heating, if we heat these hydrated salt, if we heat these hydrated salt, what happens then? Then the water of crystallization is lost. Water of crystallization is lost, and hence they lose their crystalline shape and they get into the powdered form, right? So in order to get the substance in the crystalline form, there are certain substances which have water of crystallization bonded with the water molecule. Now in this particular question, this is related to the empirical formula only, but here what we are supposed to do is we need to find out the value of N using the same method we have been employing in order to form the empirical formula. The question says that if the percentage of water in MgSO4 is 51.2, so what is this 51.2? It's a percentage of water exists in this crystalline salt. What is the value of N? So what you will be doing here, this N is coming through the ratio between magnesium sulfate and water. So in order to find out the ratio between the two, between the salt and water, what we'll be doing, like previous examples, we'll be making two columns now. Okay, not for the elements, but of the salt and the water. So we will be having one column for salt and we'll be having another column for water, right? Now, because the percentages are given to us, so what we will do, we will write down the percentages is 51.2 of water. We don't know the percentage of magnesium sulfate, but we know that if we subtract from 100 51.2, we will basically get what we will be getting the percentage for magnesium sulfate. So that is basically I think it's 48.8. So 48.8 will be the percentage of magnesium sulfate. Let me write it down neatly, and on that side let me shift the value slightly so that I have. So what I'm doing is 100 minus 51.2. I'm getting 48.8, the percentage of magnesium sulfate, right? This was my first step. This was my first step. Now I have the percentage of magnesium sulfate and I have the percentage of water. What is the next step? Now in the empirical formula, I was dividing because I was taking the elements. Okay, the elements I was dividing them by AR, but because I have a compound here, so what I'll be doing is I'll be dividing them by their MRs, right? So 48.8, because it's a compound, I'll be dividing it by MR for magnesium sulfate, and the MR for magnesium sulfate, if you calculate, it is actually 120. Similarly, the percentage of water you will divide by the MR for water, which is 18, right? So now on computing, we'll get a value for 48.8 divided by 120. I'll be getting the value 0.406 here. And on computing this, I'll be getting the value that's 2.85. Now, this again based on the ratio, right? So what we will do in order to get the ratio in the third step, I will be, whatever the value I'm getting 0.46, I'll be dividing it by the smallest value, okay? Or 2.85 could be, I'll be dividing by small value in order to get the ratio. So 0.46 is a small value, okay? Smallest value out of the two. So this will again be divided by 0.406. I'll be getting the answer 1 here, and here I'll be getting the value 7. So that means magnesium sulfate and water, they are in the ratio 1:7. So my formula for this hydrated salt will be MgSO4. The value of N will be basically, it's going to be 7 here, and because the ratio is saying 1:7 ratio, so its magnesium is 1 and water is in the ratio of 7. So this is going to be my formula for the hydrated salt of magnesium sulfate. Okay, so any such formula, if the examiner is asking the value of N for a hydrated salt, will be employing the same method. Okay, so these are the type of questions which come in context of the empirical formula.